Hello and welcome. So thank you for tuning in today, and thank you to the MongoDB team for having us here. My name is Tom Chomiak, and this talk is called Mapping the World with Trailblazer and MongoDB. So real quick, I know that your time is valuable to you, so I'd like to cover who is this session for and what can you expect to learn. Well, in short, this session is for everyone, whether you are a data architect, an engineer, or a DBA trying to prove the value of MongoDB to your business, or maybe you are an executive or someone in management trying to understand what is this MongoDB and why is this good for your organization. So there's really something for everyone. What this talk isn't is a detailed technical guide into our architecture. I will be talking a lot about why we used MongoDB from a business use case perspective, and some of the learnings that we've had while trying to scale our applications using MongoDB. Although I will provide some of those recommendations, this will not be a very deep technical dive. My goal is to cover as wide an audience as possible without boring too many of you. Cool. That being said, the talk is basically structured into 4 sections. The first section is about what we've been able to build using MongoDB. In the second section, I will talk about why we chose MongoDB as a database. And in the third section, I will talk about why we switched to MongoDB Atlas from our self-hosted solution. And lastly, I'll go over some of the challenges and recommendations that we have while scaling your applications with MongoDB. Right, so now that we've got that out of the way, who are we and what did we build using MongoDB? So my name is Tom Chomiak. I am the co-founder and CTO at Panelskin. Panelskin is a virtual tour platform that allows you to create virtual tours and VR experiences that you can then publish up to Google Maps or embed directly on your website. We're not a giant company, at least not yet. We're a small bootstrap startup out of Chicago of about 30 very passionate people. But despite this, we've been able to do some pretty impressive things and really have a global impact thanks to MongoDB. So what exactly have we built using MongoDB? Well, as I mentioned, our platform allows you to create virtual tour experiences that you can publish up onto Google Maps. The best way for you to think of this is to think of Google Street View, but for indoors. In short, using our platform, you can upload a bunch of photos of indoors and create a 360 walkthrough experience that you can then publish up onto Google Maps. So if I were to show you an example of that, if I were to go on Google and just type in Hepburn, DC, you can see a little knowledge graph that pops up on the right-hand side. And if I were to click on See Outside, now obviously it will take me out to the outside of the building, but there is a little 360 tab here. If you click that, you can then go inside of the building and navigate the space. And this virtual tour was created using our software Panelskin. So you can create a virtual tour of virtually any business, of the indoor of any business. But as you can kind of tell, it is a very canned experience. So another thing that we can allow you to do with Panelskin is you can actually create a virtual tour that you can embed in your website. So if I were to go on the Hepburn's website and click the little virtual tour button here, then as you can see, we load more of a custom virtual tour experience that you can then go into and to use to just navigate the space. Cool. So our tool has been certified by Google. We are Street View workflow ready. And you can go to google.com/streetview if you want to learn a little bit more about that. So as of today, we have about 20,000 VR photographers all over the world building around 12,000 tours of businesses per month. And as you'll see later on in my talk today, the reason we've been able to grow our product globally is because we've been able to use MongoDB, and more specifically MongoDB Atlas. So I mentioned indoors, but what about the streets? As awesome as the Google Street View car is, it hasn't gone everywhere, and landscapes and storefronts do change on a fairly frequent basis. So you could technically take your camera and take a photo every few feet, but please don't do that. It could be dangerous. So as a matter of fact, we actually have something a little bit better than that, and that is called Trailblazer. So Trailblazer allows you to capture Street View anywhere. It is a desktop application that we built using MongoDB for the backend data layer. It is available for both Mac and Windows, and you can download it at www.taketrail.com. So it works directly with the GoPro Fusion and very soon GoPro Max cameras. You just turn the camera on, hit record, and then whatever 360 footage that you capture can be dropped directly into Trailblazer and automatically converted into a virtual tour. So for those of you that aren't familiar with GoPro Fusion and GoPro Max cameras, here's a quick 20-second video clip of what they are. Cool. So most of you probably won't be jumping out of any helicopters, but you can mount the GoPro camera to your car and capture Google Street View that way. As a matter of fact, this is a picture at the Autobahn Raceway in Joliet. We were invited there by our friends at MongoDB at an event that they were hosting. We wanted to check out the raceway before the event, but we noticed that there was no Street View. So we mounted the GoPro to a pace car and ran the footage through Trailblazer. And if you were to go to Google Maps for the Autobahn Raceway, then you could see as I'm dragging this pegman here, we were able to create Street View. And if I were to drop them down here, then you could see the pace car that we used with the GoPro mounted to the top, and we were able to create Street View out of that video footage. So you're not just limited to mounting the Fusion or Max to your car. You can obviously mount it to your backpack, and then you can go places where the Street View car can't. You can go hiking trails or just areas where you really couldn't by car. You can also get creative and give your kids something fun to do too. Using Trailblazer, you can even take Street View out of this world. So this is a real 360 photo that was taken out of our GoPro 360 camera. It's taken at about 80,000 feet in the air, and you can explore this exact same scene directly on Google Street View. So what we did was back in 2018, our team launched a GoPro Fusion into near space using a weather balloon with the Far Horizons team at Adler Planetarium. In doing so, we were able to create the first ever Street View tour into space. Now, this obviously is not really what Google Street View is known for, so it is a bit of an Easter egg to find. But a quick hint, if you were to go onto Adler Planetarium on Google Maps, then there's a little sphere by the Copernicus statue that if you drop the old pegman onto, you will be able to navigate this up into space. So this is an image of the flight path that our balloon took. The total flight path was around 3 hours. And as you can imagine, there's just a ton of telemetry data that we captured that we later processed with Trailblazer and stored in MongoDB. And as cool as this project was, most people aren't busy sending balloons into space. Instead, there's tons of commercial opportunity out there where either a storefront has changed, or as you can see in this graphic, there was a brand new building that was put up, and when you went on Google Street View, it was just a wooden frame structure. So we were able to, go out there, just drive by with one of our cameras, and then using Trailblazer, update the Street View. So what's really exciting is that, using Trailblazer, we're actually able to publish over 60 million scenes, or about 114,000 miles. And, for those of you that are a little bit more visual, if you were to take each of those scenes and just line them up, side by side, they'd be about the distance of halfway to the moon. And really, we wouldn't have been able to do this without the power of MongoDB. Cool. So hopefully that gives you a good idea of what we do and what we've been able to build with MongoDB. But now you might be wondering, why did we choose MongoDB as a database? Well, MongoDB really has been critical to all of our success. It's been a really big part of every application that we've built. That being said, what are the reasons why we chose MongoDB, and what about it has made us successful? Well, first and foremost, for anyone that is not familiar with MongoDB, MongoDB is not a SQL database. It is part of the family of NoSQL databases. So rather than having things like tables, you have organizations of documents called collections. And rather than having rows in a table, you have things called documents. The data is stored in a format called BSON, which, minus some additional semantic sugar and magic, is actually very similar to JavaScript object notation, more commonly known as JSON. And JSON really is very familiar to almost every modern developer. You also have plenty of native drivers created directly by the MongoDB team, and also some really great third-party libraries such as Mongoose if you're using Node.js. Now, although you can use things like Mongoose to create a schema, MongoDB by itself is schemaless. So you can have a collection of documents with very different properties and fields. For example, it's perfectly okay for these two documents to be part of the same collection. And as you can kind of see here, I've got a document with a user called Israel, and I've got his email, and I can see what kind of cameras he has. Likewise, I have a document here for Alex, and I don't know what kind of cameras he has, but I do know that he's willing to travel, and that his hourly rate is $100. So as you can see, this allows you to be able to store all types of data, and allows you to be more flexible than with a traditional SQL database. So moving along, of course, MongoDB supports various types of indexes, but it also supports this thing called 2D sphere indexes. Now, these are very near and dear to my heart because I think that they allow you to build some really cool stuff with relative ease. With 2D sphere indexes, you can store point, latitude, and longitude coordinates within any of your documents, which then allows you to do some really cool queries, like find me all the tours of all the coffee shops in a 2-mile radius. So MongoDB comes built in with scalability in mind. When you deploy MongoDB, you typically deploy what is called a replica set. So a replica set consists of at least 3 servers, one being your primary and 2 other secondary servers. So in your typical setup, the primary handles all the reads and writes, which get replicated to your 2 secondaries. And if for whatever reason the primary were to go down, then one of your secondaries will take over, giving you a scalable, fault-tolerant solution straight out of the box. Now, you can also configure your secondaries to handle reads, and you can add up to 50 nodes per replica set, which is one way to scale reads horizontally. Another way to scale reads and writes horizontally is to implement what is called sharding. Now, sharding typically consists of having multiple shards, or in other words, multiple replica sets that you can split your data across. So the data in one shard would not exist in the other shard, which will allow you to scale your writes horizontally. And I'll talk a little bit more about that later on in the talk. Taking all this together, MongoDB takes a more modern approach, unlike your traditional SQL databases. It's easier for developers to understand, has a flexible schema that supports storing all types of data, has some cool features like 2D indexes, and has scalability built in mind, which, taking all this in mind, really allows you to build some modern applications faster. Great, so hopefully I've convinced you that MongoDB is a great database and something worth trying out if you aren't already. That being said, you can deploy MongoDB just about anywhere. You can easily download MongoDB and run it on your laptop. You can also self-host it on-prem or at some data center. And you can also very easily spin up a cluster within MongoDB Atlas, which is the database as a service platform supported directly by MongoDB. So we personally have been using MongoDB for many years. We started off self-hosting our MongoDB clusters. Some of that is still self-hosted. However, we've been migrating and certainly building all of our new applications on MongoDB Atlas. So if I can run MongoDB anywhere, why do we switch to Atlas? Well, as easy as MongoDB makes it, and as awesome as their documentation is, managing a database infrastructure, well, there's no other way of putting it, but it sucks. Every once in a while, the internet gods will throw you a lightning bolt and cause all kinds of chaos. Obviously, if your database goes down, then everything goes down, which can be stressful. And you find yourself and your team spending just a ton of time both managing and updating infrastructure to make sure that everything is running smoothly and without any downtime. Now, if you're running a small replica set, then you might be like, I got this. But trust me, as you scale horizontally, then suddenly these issues tend to become more frequent. And if you're self-hosting, then not only are you dealing with these issues, but you're also patching, updating, configuring multiple clusters of servers, which makes things a whole lot more complex as you scale. Now, obviously, if you got a great DevOps team, then there's things like Ansible or Chef that you can use to assist to push updates. But there comes a time when you need to ask yourself, do I want my team spending their time managing and patching our database, or do I want them building the next best thing and have the experts at MongoDB help manage that infrastructure? Some other cool things with Atlas is that you get this sexy administrative dashboard. It makes you feel really good inside. It gives you a quick overview of your entire environment and allows for, quite frankly, easier administration. You can do things like set up backups, create monitoring, easier user management, and generate just unlimited reports. Atlas also makes deploying a lot faster. At the click of a few buttons, you can select any of the major cloud providers out there and deploy a cluster into one of many regions. Now, depending on the instance that you select, this will automatically set up a replica set for you. So there's no need to spin up separate servers and configure a replica set like you would if you were self-hosting. It's all done for you. One of the other things that really drew us to MongoDB Atlas is the ability of setting up global sharded clusters. So we have users in over 100 countries. And this is something that really allowed us to super serve our clients. Just like having a CDN for your static assets and media, setting up a global cluster within Atlas will allow for lower latency read and write operations for your end users. But it also provides you better uptime if you have some type of regional or even partial outage. So one thing to note that when creating a global sharded cluster, each of these documents will have a location field set to either a country code or subdivision code. And just a reminder, you cannot easily change the shard key after sharding, nor can you modify the value of the shard key fields in that sharded collection. So just make sure to read through MongoDB's documentation thoroughly if this is something that you're interested in doing. Another thing to note is that a shard key just on the location field can result in bottlenecks for countries that receive the majority of write operations. So in practice, you'll want to create what's called the compound shard key for more efficient distribution of your data across the sharded cluster. In short, MongoDB has really been allowing us to super serve a global audience. Now this is a picture of Paul Syed. So Paul is from South Africa, but he's originally from Lebanon. And he realized that there is no Street View in Lebanon, and he's been on a mission to bring Street View to his home country. And this is just a quick graphic of some of the streets that he's captured. And so having the right infrastructure in place has really been able to allow us to serve guys like Paul. So what are some things that we've learned from using MongoDB, migrating to Atlas, and just scaling in general? Well, first and foremost, use indexes wisely. If you take anything from this talk, this is one of the single most important things you can do. If we had a query that was frequently used, for example, that searched for all the tours by country, then we would create an index for the country field. Now, I did say wisely because the trade-off to indexes, like with any database, is that they consume a lot of RAM. So you don't want to index things you don't necessarily have to. Also, you want to look into something called compound indexes. So, for example, if we were to create an index for both country and state, then this would create a compound index, including both fields. And what this would mean is that if we were to query by country and state together, we would use the index that we created, making the query a lot faster. Also, by default, querying by country alone would use this index. However, if we were to query just by the state, then it would not use the index. So you can read up about why this happens, but in short, it's due to a thing called prefixes. As a rule of thumb, the query will use the compound index if the fields in your query and all the fields prefixing them are there when you created the index. In this case, the state field is prefixed by the country field, so since the country field is not included in the query, the compound index is not used. Next tip of advice is, analyze your queries. Don't just trust what I say or what you read online. You can very easily analyze your queries just by using the explain method. This will tell you a bunch of information, like how many documents were searched to get the result. And it really is an invaluable tool when trying to optimize your queries in and indexes. So I would definitely highly recommend using the explain method and look into what is called the explain plan. So a covered query is basically a query that can be satisfied entirely by using an index. The results are returned directly from the index without having access to documents. These types of queries are extremely fast. And for a query to qualify as a covered query, it really has to meet three criteria. First, no field in your query can be equal to null. Second, all fields in the query need to be part of the index. And lastly, all return fields need to be in the same index. So one common pitfall is to include the underscore ID of your document in the results. Now, if the ID field is not included in your compound index, then the query that you created does not qualify as a covered query if it includes the ID field in the results. So, kind of taking a look at this example here, the first example would not be a covered query. And this is because, as you can tell from the query, the underscore ID is not included in the compound index we created to the left, but it is being included in the results. So one way to fix this would be to tell your query not to include the underscore ID field in your results, as you can see that we've done with line 4. Or you can simply include the underscore ID field at the end of your compound index when you're creating it. Another thing that we learned is that within a replica set, by default, the primary handles all reads and writes. So if you want to scale your reads horizontally by adding more nodes to the replica set, then you will want to make sure that your cluster is configured to serve reads from your secondaries. And again, you can add more nodes to your replica set with the limit being 50. Cache reads whenever possible. So for data that doesn't change a lot, it's probably best to cache that data versus hitting the database every time. This really saves on connections and also the round trip of having to go to the database and back to your server and so on and so forth. So for example, with our tours, when we serve them to the regular end user, that is usually served from cache. Now, obviously, if we were to make an update to the tour, or if you want to clear the cache, you'll want to clear that cache when that data changes. Now, obviously, the easiest caching setup is to have a local cache on your servers behind your load balanced application, and you can expire that cache after a certain amount of time. This really is the easiest setup. This limits the amount of times you have to make the trip to the database for information, and it's certainly better than no caching. However, I do caution anyone that does this, as this can cause a lot of issues with the more application servers that you have. So for example, this can cause what is called a cache stampede, where all of a sudden all of your application servers try to connect to the database for fresh data. It can also cause syncing issues with data where one app server has an older cache than the other, which, as you can imagine, can cause lots of issues. So to solve this, on our end, we have what's called a Redis cluster, and we use pub/sub. Basically, documents are served from our local cache on our application servers until a change is published by our Redis cluster. Then the cache for that document is updated across all of our application servers, and we avoid things like the cache stampedes or not having synced data. Sharding. So we already kind of touched on this. A common misconception is that when you add more nodes to a replica set, this will increase your write performance. So this will not increase your write performance, as you are really only adding more secondaries. And writes are always handled by the primary within your replica set. So basically, there are two ways to scale writes. You can either increase the size of your server, which is the quickest and easiest way if you are having an oh crap moment, or sharding. So increasing the size of your servers will obviously only take you so far. And you'll likely need to start sharding your data once it gets a certain size and you're trying to increase that write performance. So when sharding, you basically are creating clusters of multiple replica sets where each shard in your sharded cluster will have its own replica set and your data will be spread across those different shards. So in the example I have above, the first sharded replica set, SR1, it will have different documents than are stored on the second replica set, SR2. SR1 will also have its own primary server, as will SR2. So this is not only distributing storage of your data across the replica sets, but you're also distributing your write performance because in this example, you'll have two primaries that are handling your writes and reads. In addition, each of these shards are replica sets, so you'll have automatic failover for each of the shards. Now, to start sharding, you will need to choose what is called a shard key, so that you can start sharding your data across your cluster. Build microservices early. So most startups will be quick to launch an MVP, And then before you know it, they start adding more features, more tools, bells and whistles, and they begin to build a monolith. Then they go on to build some other applications, maybe some internal tools that also need to access this data. And before you know it, if you are using something like Mongoose, you are managing multiple schemas on different applications, and things can become out of sync and cause you some trouble. In addition, let's say one of these applications becomes legacy, but you want to update the version of your database. As you can imagine, if you were to update the version of your database, then you may need to update the version of your drivers on your apps, which in some cases can cause you to have to update the version of Node.js, PHP, Python, whatever it is that you're using and running. And this can obviously break some of your dependencies. In essence, causing you much unnecessary headache. This all can really be solved by splitting up your business logic into microservices. Now, at the very least, having a microservice for your data access layer. And whether that's a REST API or GraphQL, doesn't really matter. Just getting some type of microservice for your data access layer into place will definitely help with that. Some other advantages is it'll add another layer of end-tier security to your setup, and is just quite frankly a best practice. So start using microservices early if you aren't already. Lastly, don't be afraid or too proud to get help. All of us can learn something from each other. So definitely first read the MongoDB documentation, but don't be afraid to go onto Stack Overflow, email a friend, or reach out to support if you have a specific MongoDB Atlas question. So best of luck, guys, and thank you for your time.